Okay, I'd like to introduce the second speaker. Her name is Linda Eremita. She is the Forest Education Manager and lead ISA certified arborist at Tree People, which is in the Los Angeles area. She holds a BS from Cal Poly San Luis Obispo in crop science with an emphasis on plant protection and pest management. After graduation, she moved to Seattle where she studied horticulture for 2 years, concentrating on design informed by maintenance needs and natural systems. She paid her dues, digging irrigation trenches in the snow and working for 14 years in the Seattle rain. Back in Los Angeles since 1998, she gave up the abundance of rain for the abundance of sunshine and has worked at Tree People ever since. She became an ISA certified arborist in 2000. Linda will speak on preparing for a warmer future, urban tree species selection and care. Linda?
Thank you. We have, as we heard from Nicole, our climate is getting warmer. So just a brief primer. If you haven't heard about this, it is caused by something called the greenhouse effect. And that is normally when the sun shines down on our Earth, it radiates our Earth, and then some of that radiation heads back out to space. But because of greenhouse gases, which carbon dioxide is the main one that we're concerned with, has increased, it creates basically a blanket that prevents that radiation from heading out into space. So we are warming up. In fact, we have more CO2 than ever before. Woohoo! It is the concentration of carbon dioxide in our atmosphere is double that of what it has been for the past 420,000 years. That's a long time. And the percent concentration has not been so high as it was 20 million years ago. It's been a long time. Now, it's been on the increase ever since the Industrial Revolution. It's been increasing about 1 to 3 parts per million per year. And you're like, oh, that's not a lot. 1 to 3 parts per million, that's very small. But every year for, the past 250 odd years, that adds up. So if it was only 1 part per million per year, that'd be an extra 250 parts per million. That's a big increase from what the norm is or has been. If it's 3 parts per million, that's 750 parts per million more than it has been. That's a lot. And the plants that we currently have on this earth have evolved in a much lower CO2 environment. So we have some issues that are happening. So the earth is getting warmer. But we have this extra bonus here in our cities. We have something called the urban heat island effect, or sometimes heat island effect. And that is, you can see this little graph here, in our downtown areas or areas where we have lots of concrete and asphalt and buildings, heat absorbing surfaces, those areas heat up a lot more than our surrounding natural forests or even chaparral. But the kicker is, so if in our areas, our cities where we have 1 million or more people, so it's not just the city of Pasadena, but the general area here, it can be hotter in a downtown area 1.8 to 5.4 degrees Fahrenheit more than the surrounding natural areas. But the kicker comes at night. At night, those heat absorbing surfaces, those streets, the concrete, our buildings release that heat. And it could be a difference of 22 degrees hotter in our downtown areas, in our lower income areas where they don't have a lot of shade, there's not a lot of trees, so it becomes a social justice issue in some case, and it's turning into a health issue for our cities. NOAA and the National Weather Service, which is a part of NOAA, they actually produce heat alerts when it gets to be 105 to 110 degrees Fahrenheit. And you can see by this chart here, those colored numbers, you can see the numbers in the center have to do with the actual temperature and then the percent humidity. So those two work together, and you may see a weather forecast where it says it's 98 degrees, but it feels like 105. That's what this is about. Our bodies feel that temperature and will react to it. And when we start getting into the orange areas or the red areas, that's when we're seeing things like heat stroke, heat exhaustion, and the more folks at risk, the elderly, infants, or people who have pre-existing conditions, people who have heart conditions, they're more susceptible to the heat. And if we have 2 or more days in a row where we have the heat index is very high, that's when we start seeing people coming to the emergency room. And mortality, it has increased because we have global warming, and we have this other thing that we deal with called the urban heat island effect. It's a huge, huge issue and has been on the increase. So who do we turn to? How are we going to fix this? Trees! We need to cool down our cities now in a big, big way. So first thing, again, remember that heat island graph are downtown areas where we have the most concentration and the least amount of landscape areas. We need to get some trees out there. Shading our homes. Whether they're 1-story, 2-story, we need to shade buildings. We need to shade parking lots. In fact, parking lots and streets, that asphalt, will last longer if it's shaded. So your city will be spending less money on repaving those surfaces. And you know when they repave, it's black and hot, that asphalt, so it even heats up more. Another thing that some folks are doing in parking lots is they're actually painting the parking lots. Instead of being black, it's a tan color or something, a lighter shade. And you can really tell the difference right there. In fact, cars, even if they're parked and not running, give off VOCs, volatile organic compounds, if they're not shaded. So even that's why cooling our parking lots, not only because of the heat absorbing surfaces, but because of the cars that we have parked in there. So shade is an important thing. So we no longer have the luxury of thinking of trees as just something to beautify our cities. Now don't get me wrong, I think trees are beautiful. I love trees, they're pretty. But they provide us with so many benefits. They are the diligent workers in our cities that are helping to cool it down. But I want to bring to the fore some of the other benefits that we get from trees that we don't always think about. These are some bonus benefits. And if you ask any elementary school kid, what do trees give us? They'll say oxygen, home for birds, shade, and most of us know that. But here are some other things you may not know. A lot of studies, especially recently, have been showing that just taking a walk through nature, even walking in your neighborhood on a tree-lined street, going to your local park, will give us a better sense of well-being. It's a big stress reducer. And it even affects our physical health. Our minds are an amazing thing about human beings. They've done studies in hospitals. In fact, a lot of hospitals now have healing gardens and medical centers. They've done studies in hospitals in a ward where people are in there for a certain surgery or some kind of a condition, where half of the folks on the floor will have a view of buildings, the other half will have a view of a landscape. The people with a view of a landscape, their recovery is sped up. They heal much faster. So we have some kind of a connection. There's a mind-body connection that we have. It can decrease asthma attacks because trees are collecting that particulate matter that exacerbates asthma attacks. You have a better sense of community in your neighborhoods, especially if you've gotten together with your neighbors and actually planted the trees on your street. People are walking down the streets, they're greeting each other, and this comes to a decrease in crime. They've done studies. There was a big study done in Chicago where they were looking at some of the lower income housing projects. Very rough neighborhood, lots of crime. And in one of the sections, they landscaped it, trees, shrubs. People were like, don't do that because people are going to be hiding behind the trees and they're going to be attacking people. And actually the opposite happened. In the areas where it was landscaped and there were trees and shrubs, people had an excuse to come outside. And they were watching out for each other. And in the other part where it wasn't landscaped, the crime level was the same. People stayed inside, afraid. It's an amazing thing. It increases revenue in business districts. Kathleen Wolfe up in the University of Washington has done most of this research on observing shopper habits. Whether folks are pedestrians walking through a business district or they're driving down the street, they tend to drive down streets that are more tree-lined. And in fact, the more landscaped a business district is, the better revenue was brought in. If it's just trees, it was better. If they landscaped around the little cutouts in the sidewalk, they even had better revenue. If it was maybe a little cafe that had tables set up outside with potted trees and shrubs and flowers, even better. The more it was landscaped, the more people wanted to spend time there. So it's a very good thing. It slows traffic through neighborhoods, making our neighborhoods safer because people tend to drive slower down a tree-lined street rather than a street that's barren. And it can increase your property value. Well, that is if you care for those trees. If you malprune them or you don't take care, then it might decrease your property value because they think you don't care about where you live. But these are just some of the hidden benefits. But we're talking about heat here today and climate change and what's happening. So how do trees help? Obviously, cooling. Cooling is the big thing. Evaporative, which I'll talk about in just a sec, and direct shade. But the added benefit is that, of course, when you're cooling, you are using your air conditioner less. If you're strategically placing trees to shade the buildings or shade the air conditioner units, that air conditioner is not working as hard, or maybe in some places you don't even need an air conditioner, if you're closer to the coast anyway. So energy use produces, say it with me, greenhouse gases, unless it's solar or wind. So by shading our homes and using less energy, we're reducing greenhouse gases, we're reducing the cause of global warming. It all works. It's one big cycle. So less energy use equals less greenhouse gases, equals less heat, equals more money stays in your pocket. It's a win-win. So how do trees cool? Well, trees are our natural air conditioners. There's a process called transpiration. So trees are taking in water through their roots. It goes up through their trunk and their branches, and it's released from their leaves in these little holes called stomata, which I love. It sounds like a nice Italian pasta sauce. These little holes on the underside of leaves, typically on the underside, and that's where that water vapor leaves. And that's where the carbon dioxide goes in and the oxygen is left off. So how many have been under a mister system? Not a Mrs. system, but a mister system, right? So they're usually put out where people are gathered in areas where it's very hot and exposed, often in, if you're standing on asphalt, like I'm thinking Disneyland. I've seen them there. Or Universal Studios, and they have those misters out to cool down the crowds as you're standing in line. Or they have those little handheld fans with a spray mister, same thing. Evaporative cooling will cool you down better than just a fan. So a tree will cool you better than a solid structure. So trees are very important, putting that moisture out there for us. So when we are cooling, again, strategically placing the trees is critical for us here in Southern California. There's a study coming out next month, actually, through a scientist at UC Berkeley, and he's from, I don't remember, but a university in China. This study is coming out next month. They looked at Sacramento, and they looked at the East Coast in Baltimore, and they were trying to see what is the best way to cool down the land surface? By either just having sheer mass quantities of trees planted in a city, or is it better to just strategically place them to cool specific surfaces, not even necessarily the same amounts of trees? And what they found out was, the answer is yes, to both. But it depends. It depends where you are. On the East Coast, they found that they were able to cool surfaces much better if they just had massive quantities of trees. It didn't necessarily matter where they were. So just getting more of that moisture in the air, creating more shade everywhere, that was what worked there. But in Sacramento, with the Mediterranean climate, with the hot, dry summers, what worked best was to strategically place those trees to shade those heat-absorbing surfaces. So again, shading our streets, parking lots, our homes. So on your home, the first place you should think about shading is the west side of your home, because that's the afternoon sun and that's the hottest sun that we get. Deciduous trees are best because they lose their leaves in the winter, and then that winter sun then can come in and warm your home in the winter, so you're using less energy in the winter for your heat bill, right? South side is the next thing you're looking at. Deciduous trees also, the same reason. The east side would be the third place. And because that sun isn't as hot, deciduous or evergreen trees are okay. I mean, really, if you can just get a tree out there, that's the best thing. But this is the best scenario. And of course, on the north, plant it, whatever you want, because that's not going to do any shading for your home. But a general sense of cooling will come about by that. There is a wonderful tool, a climate modeling tool called CalAdapt. And there you can see the website down there at the bottom. This is a website you can go to, and it has taken the information, the climate change research that's being done by different universities in California and different institutions that are doing the climate change research directed at California. And you can go on this website, and they have a map. You can pinpoint where you are and run these models for your area. What will be, as Nicole was showing us, what will be an idea of what our temperatures will be 75 years from now. What will be the average cold temperature, the minimum temperatures then? What will be our precipitation? So it's a very interesting tool. So I was looking up north first to see what kind of changes would be. Here's Eureka, up on our north coast, close to the Oregon border. A coastal town with redwoods and big conifers right down to the coast, lots of rain. And then looking at 75 years from now, what kind of climate is that going to possibly have? Well, there's Berkeley, California, about 270 miles to the south. Much drier, warmer. It's known for its oak trees, even eucalyptus trees. Eureka may have the same climate as Berkeley in our future. That was a stark reality, a possible reality. So here's that CalAdapt website. I'm sorry, this is not very dark, but this is a screenshot from the website. And this is looking at, you can see the bigger words where it says maximum temperature. Underneath that, you can see it says area near Pasadena. So this is a model, climate model for Pasadena. And on the far right there, you see those two temperature numbers, 77.5 and 83.4. The top number is, I looked at what it was, the average maximum temperatures from 1950 to 2005. So that was the average temp over that time span, the maximum temperature, 77.5 degrees. And then I looked what the future would be, 50 to 75 years from now to get an idea. That would be the years 2067 to 2092, and it shows an almost 6-degree increase. And remember, the temperatures are for in the shade with low wind. It'll be much hotter if you're standing out in the sun. Same thing with the heat island effect. Those numbers are if it's in the shade. So things will even be hotter in some areas. And I looked, jump there. Minimum temperature, same thing, it's gonna go up about 5.5 degrees, running that same scenario. Things are warming up. So the other thing I was concerned about, thinking about trees in our urban forest, a lot of us, how many of you have fruit trees? Excellent. Any of you have deciduous fruit trees like peach or apple or anything like that? Yeah, so those deciduous fruit trees, sorry about the mic here, I'm used to moving around a lot, I'm Sicilian and I talk with my hands, but deciduous fruit trees need a certain amount of cold before they'll break that winter dormancy and then flower and fruit. So it depends on the specific tree, which cultivar it is. For instance, like apples, there's everything from a Gravenstein to a Gala to something called an Anna apple, and they have different amounts of cold that they need through the winter. And that cold is looked at from November 1st to February 28th. So November, December, January, February, 4 months of cold. They measure the temperatures when it's under 45 degrees. So it needs a certain accumulation, which they call chill hours, an accumulation of a number of chill hours that specific tree needs for it to be able to produce fruit. So here in Southern California, we talk about needing low chill fruit trees, trees that don't need a lot of chill hours. And in the past, they've said 300, 400 chill hours, that's what you should be looking at. Not some apples, for instance, need 800, 900 chill hours, and apricots and others. So we need to be looking at low chill varieties. Well, this date here is November 28th of this year. So this was from November 1st, 2016 to February 28th, 2017. And for this area, which the weather station is in Monrovia for this area, it only got 214 chill hours. So if you are having problems with some of your fruit trees not producing fruit anymore, that could be why. It's not getting cold enough for it. It's not fertilizer. You'll probably kill it if you keep pouring fertilizer on it. It may be water, but it may just be that it's just not cold enough anymore. So these are things we need to be thinking about in our urban forest. What's appropriate? And so how do you know? For instance, this is an Anna apple. This is a tag I actually took off my tree and took a photo of. You'll see right there it says 200 hours. That's what that means. Those are the chill hours. So this is a very low chill apple that would be appropriate for our climate. There's a really good website. It's the Dave Wilson Nursery. And Dave Wilson is the largest fruit tree grower in the state of California. So if you're looking for fruit tree information, excellent resource, Dave Wilson Nursery. I don't get any money from them, by the way. But they've got really good info. So here's another climate model from that CalAdapt website looking at precipitation. And in this case, the modeling is showing that it's not going to really change that much. But it just depends. There's so many things in play that can shift this. It could be, as Nicole was saying, that we may get maybe about the same amount of rainfall, but they could be bigger events. And it could be condensed, not spread out over, maybe we don't get very much rain in the spring anymore and it's really just in the winter. And then that would be more of a flooding problem. The other thing that will be shifting is the USDA hardiness. That's basically the minimum temperature. How cold does it get? And so here's Claremont and here's Santa Monica. If you're familiar with the USD hardiness zones, and I apologize again, this is very hard to see, it's zones, it used to be 1 to 10, then they made it zones 1 to 11. Now I think it's zones 1 to 12. And the higher the number, the warmer the area is. So Florida and Southern California, we're in zones 12, depending on where, or zones 11. But they're saying for the Inland Empire, which would be here in Pasadena, or closer to the coast, the model projects that it's going to bump up by about a half a zone, 75 in the next 75 years. So we're getting warmer. So when you use maybe the Sunset Western Garden Book, who's familiar with the Sunset Western Garden Book? Any gardeners here? That's like the gardener's Bible, right? That has different climate zones. They have their own set of zones, and there's 24. They've broken it up further than the USDA, and it looks more at not just the minimum temperature, but coastal influence and rainfall. There's a lot that comes into those zones, so it actually gives you a more accurate picture. CIMIS, another groovy tool. CIMIS is the California Irrigation Management Information System. So I call it CIMIS. They have, this is where we find the weather stations. There are over 150 weather stations in the state that gather in information about rainfall and temperature and evapotranspiration, which is, remember, transpiration is water evaporating from trees, right? Or the evaporation, how water evaporates from the soil. So they have these different weather stations throughout the state. And this is where I knew, I see I put this slide in the wrong place. This is where I figured out that Monrovia, weather station 159, I looked on the little map and I went, boom, that's closest to Pasadena. So that's where I figured out what the weather station was. Then on the UC Davis website for the fruit trees, that's where I figured out that information with the chill hours. And here is that UC Davis website where, it's, again, this is really hard to see, but this shows the chilling hours. So this is what we've been doing in the past. Lots of grass, lots of water-sucking trees. These are birches. Birches are lovely, but they're one of the highest water-use trees out there. And not really appropriate for here in Southern California. I know some of you are like, oh, I have one in my backyard. It's okay, no shame. Because water used to be kind of unlimited in our idea from the past. I get calls all the time at tree people. How do I help my redwood? Well, I don't know. Are you trucking water in from the north to water it? I mean, redwoods grow in our temperate rainforest up in Northern California. They're used to getting a lot of rain, but they actually get a lot of moisture just from the fog, just from the air is moist. I know in Santa Barbara, I know Nicole lives up there in the Santa Barbara Botanic Garden, they even have misters up in their redwood trees to help increase the humidity. That's how important it is. And so down here, the redwoods are not doing so great. So this is what we were doing, and then we had this little thing called the drought for a number of years, and then we had this, and we're like, gosh, we need to cut back on our water. So people stopped watering their lawns, and then we had this. Trees dying. This is a really big oak, and you can see down here, or maybe you can't, but it's brown. Over here, there's a big dead tree. But this lawn is very green. The shrub looks great. The parkway is very green. But right next to it, they've taken out their lawn. They have a little raised bed here, but they've taken out their lawn. They're not watering any of this. They're not watering any of this. But right here on their own property, it's like, we're watering. So why is that? How come that tree's not doing so well? Well, it has to do with where the roots are of a tree. So most of us have grown up with this idea that whatever is growing above ground is mirrored below ground. Well, that's basically a big fat lie. That is really not how roots grow. Instead, it looks more like this. And it will depend on the soil, but roots grow in a really wide pancake around that tree. Often 2 to 4 times the diameter of whatever the canopy is. The canopy or the branches up there. So that whatever the spread of the branches are, the root system can be 2 to 4 times that. Really wide. And so the roots on that tree that was dead, a lot of them were actually over in the neighbor's yard, and they stopped watering. It's like, it lost a lot of its water. And most of the roots grow in the top 18 inches of soil. Now, they will send down what are called sinker roots, 3 feet deep every now and then to help anchor it a little better. And some trees do actually have a taproot. Just about every tree starts out with a taproot. You know, you have your little seed, you plant it in the cup, and you watch it first puts the root down, that grows straight down, and then it puts out the shoot as it's running out of energy that's stored in that seed. It needs to photosynthesize and make some energy for itself. But after a while, then, the roots really start growing laterally. And a lot of those absorbing roots are in about the top 6 to 8 inches of soil. I mean, some of them are deeper too, but again, if you stop watering your lawn, and when you water your lawn, usually you're not watering it for long periods of time because the grass roots aren't very deep. So you're keeping the tree roots very shallow, and all of a sudden you stop watering, and the tree's like, uh-oh, what? Where am I getting that water? The roots are growing out normally in a really wide spread to mine water out of the soil as much as it can. But if you've been watering, if you've had grass here and now you're not watering, and you were watering just a little bit, the roots will even be closer to the surface and more susceptible to drought, and they start dying, and the tree starts dying. It is not a good thing. So where do we water a tree? Well, under that canopy, but beyond the canopy too. So the edge of the canopy is called the drip line. A good rule of thumb is to water under that canopy halfway from the trunk to the edge, start there, and then bump it out beyond the canopy about that same distance in a really wide circle. And there's a handout on the back table over there by the windows that shows you this. And then how deep? Well, about 12 to 18 inches deep, because that's where a lot of those roots are. Now, this is the ideal. Obviously, you can't always do that. Think of a street tree. What, you're going to try watering underneath the street? Yeah, that's not going to happen. But try to get the water out as much as you can into where the roots will be. And how? This is a really good way. It's called inline emitter tubing. This is a half-inch tubing, and it has embedded inside of it, spaced out, depending on what brand or what you get, every 12 inches or every 18 inches. There's a little hole in the tubing at that point, and inside the tubing is this little device called an emitter. And that regulates how fast the water leaves or weeps out of that little hole, very slowly. Maybe a half a gallon in an hour. Really, really slow. So that allows the water to soak into the ground instead of just shooting a bunch of water there, and then it'll find the path of least resistance and run off. So we want to always water slowly and deeply. Everybody say that with me. Slowly and deeply. And now, yes, no. So this is the best way to get the water out. I was at the Huntington Botanic Garden, and they had just started to re-landscape this area. They planted these oaks, and they hadn't mulched on top of it yet. I'm like, oh, woohoo, perfect opportunity. I can take a picture of inline emitter tubing around these trees. And this is exactly, did they listen to me? Exactly what I was just talking about. So they started about halfway from the edge of the canopy to the trunk and put a circle here, and then they had concentric circles around to water that tree. And then as the tree gets bigger, they'll put another ring out. It's a good thing. And, what if you have a lawn? Well, you could do this temporarily. You don't need to water your tree necessarily all year. If it's a native tree, if we're having a drought, it really needs water in the winter. That's the best time. That's when it's used to getting water. But you may need to water in the summer, maybe once a month, maybe once every other month, maybe twice a month. It depends. It depends on your soil. It depends on how hot it's been. dig down in the soil. Is it wet? Don't water it. Pretty simple. So what is an appropriate tree? How do we think about this when you're trying to choose what's appropriate, or when a city is looking at our changing climate? First, is the tree adapted to our existing climate or a climate that's warmer? I always think about Eureka and Berkeley. You know, Eureka needs to be thinking about what's doing well in Berkeley, and maybe start thinking about planting some of those kinds of trees up there and see how they do. We want to plant trees that have a low to a very low water rating. We go through another drought and where there are restrictions on watering, we want to have trees that are adapted to that. We need to look at pests and diseases, and I'll look at this a little more. What type of soil do you have? Or sometimes it's called the soil texture. And how well does water travel through that soil? If you have a sandy soil, boom, water goes right through it, right? If you have more clay in your soil, it's going to hold on to the water more. You need to water it less. But you need to know, trees are pretty persnickety about what, depending, some trees are very particular about the type of soil that they grow in. They want something well drained, only a loam or a sand, and a nice view of the ocean. Are there any physical barriers? What's appropriate for that site? Is it in a little teeny 3-foot wide parkway? Don't plant a coast live oak. It's not going to fit. Are there underground utilities? Anything. What's appropriate, at least for your area or the specific site? You want to make sure that tree is not invasive, and I'll show this a little more. There's something called CalIPSI, which is the California Invasive Plant Council. You want to make sure it's not on that list. So here's a map of the sunset climate zones. You folks here are zone 21, but you can see, as I was saying, there are 24 climate zones, and 24 is along the coast, and they go more and more inland. The inland zones for LA County are 18, 19, 20, and 21. WUCOLS, or WUCOLS. It's the Water Use Classification of Landscape Species. This was created by the University of California. And on this website, you can find the water use rating for a particular tree or shrub or ground cover, whatever it is, just about anything that will grow in California you can find on this list. So you go to the website, and then you can select a city by a region. So this says South Inland Valley, which would be this area. And you click right there, there's a little arrow, and then when you get to that, it'll bring up a drop-down menu of different cities. I picked, this says, I know it's hard to see, this says Pasadena, and then I hit the submit button, ta-da, and then what happens, you get this page, where you can either type in the botanical name of the plant in question, or if you only know the common name, you can type it in here, or you can do a search. Say, in this search, in the bottom here, I say trees, low to very low water. So I picked what I was looking for. So I checkmarked trees, and then I checkmarked very low and low water use. And then, I can't see from here, one of these, I clicked on that, and it gave me a list of, I think this is 162, 163 different trees. It's a very handy tool. I love WUCOLS or WUCOLS. You say however you want to say it, but it's a great website, great tool. Pests and diseases, we got lots of them. Some of them are a big issue, some of them, a little bit of a nuisance. Some of them are native, some of them are not native, and it's often the non-native, at least in the urban landscape, that are a big problem. So there's a few places you could find out some info on that, and I'm going to highlight some of the big ones right now. But the SelecTree website, this is a really wonderful website to search for trees. You can do a search for a same kind of thing where you can say, I want a tree that's 65 feet tall or shorter, that grows in clay, that is evergreen, that wears a size 6 shoe, I don't know, whatever. There's a whole list of characteristics you can search for, and again, it'll spit out a big list that fits the criteria that you give it. There's the Sunset Western Garden Book, the Gardener's Bible. This is the IPM. IPM is Integrated Pest Management. for the University of California. Lots of information on pests and diseases, especially for our urban landscapes. And this is a very important one. Escalin Lab. Akif Escalin is the lead scientist at UC Riverside doing the research on, wait for it, the Polyphagous or the Polyphagous shot-hole borer. Who saw that article in the LA Times just recently? Gosh, was that last week? I got so many calls when that article came out. What am I going to do? Does it have that borer? So this is a different beetle than the ones that Nicole was talking about. This beetle is teeny tiny, is about less than the size of a sesame seed, maybe half the size. Very, very, very small. It is not native. It is native to Vietnam. And the Kuroshio shot-hole borer, closely related. If you looked at them, you wouldn't be able to tell the difference. They almost have to do DNA sequencing to figure out which is which. But the Kuroshio is from the same general area, but not necessarily Vietnam, but it's from Southeast Asia. Relatively new pest, and it is a type of beetle like the ones that are attacking our mountains that they call ambrosia beetles, and the fact that they inoculate those galleries, those little tunnels that they make, with a fungus that their larvae eat, and they eat. So they're not really eating the tree. The tree is just their home. Trees are, I don't know if you could see this very well, right here. So here is a tree cut. This is a tree cut. See all this in here? Those are all the tunnels throughout the tree. The bark beetles kind of burrow under the bark in the cambium layer, the phloem, which is where the sugars are passed from photosynthesis. The sugars are created up in the leaf canopy and they spread throughout the tree wherever the tree needs it. The Polyphagous shot-hole borer, this type of beetle, burrows all through the xylem wood, the wood of the tree. That's the water-conducting tissue. And so much tunneling that trees are literally just falling apart. Or they're dying from the fungus that they spread in the tree that's also plugging up the xylem tissue. So it's the 1-2 punch. Either you're going to die because I'm going to make you fall apart, or I'm going to clog up your water-conducting tissue. And they don't get a choice. This has become such a big issue in our urban forest. Here's a map of the red is the Polyphagous shot-hole borer. And of course, these are only reported cases. I'm sure it's in more places than this, but this is just only where people didn't know it. Like, oh, I'm going to send a sample into the Escalin lab or to the LA County plant pathologist. Did you know we have a free service in LA County? We have a plant entomologist and a plant pathologist. It's located in Southgate. If you look under the Agricultural Commissioner's Office, we have 2 different labs where you can send samples and they will diagnose, they will either identify what the insect is or they will identify, if they can, what the disease is for free. Free is a good price. I like free. I'm a cheap date. It's good. You can send them samples. So you can either send the sample in to the plant pathologist or the plant entomologist, or send it into the Escalin lab to find out what it is.
A sample of what?
Of the insect. If you can get the insect, I've seen them crawling out of the trees at the Huntington. You put it in a little vial, like a little pill container, something, stick it in the freezer for at least a half an hour and kill it, and then mail it to them. Put in a little bubble wrap container or whatever. Or if you have a diseased tree, you can send them a sample, either of the small fibrous roots or maybe a little branch, maybe pencil size in diameter or smaller, of what you think is going on. Often the problem is in the roots when we see a disease. We don't realize it, but we're seeing it expressed up in the leaf canopy. You can send them a sample in a little Ziploc baggie, if it's a leaf sample or a root sample. Send it at the beginning of the week so it doesn't sit over the weekend getting funky in the mail. And there's a form, if you go to their website, there's a form you can fill out to send in samples. For free, people, it's a free service for LA County residents, and that would be you. So anyway, here I digress. Here, you could see the PSHB, the Polyphagous or the Polyphagous shot-hole borer. The blue dots are the Kuroshio. The Kuroshio is mostly down in San Diego County, but they found it up in here. And Nicole was just telling me they found the Polyphagous up in Montecito. Is that what you said? Yeah. So it's on the move. And so I zoomed in a little bit more to where we are. This says Pasadena. This big group clumping, that's the Huntington. I took a workshop there. It was scary that we had to wear hard hats because trees were falling apart, literally. We had to wear, they wouldn't let us walk through that grove of trees without a hard hat. And this line over here is the Arboretum. So this is where they have, scientists and experts doing research. But I'm sure it's more in here, but this is just where it's been reported. Am I scaring you yet? Yeah. Okay. Breathe. Because here's the big list. And you can go on the Escalin Lab website. There are 49 different species of trees that this beetle can reproduce in. It's a lot. And it goes for dessert first. Its favorite trees are our riparian trees, the trees that normally grow along water courses, like sycamores, our native sycamore, our willows, alders, Acer negunda, what's the common name? Box elder. And then when it's done with that, it goes for our coast live oak, our valley oak, our Engelmann oak. It has a lot of trees, and non-native trees, and even some pest trees like the tree of heaven, Ailanthus altissima, or castor bean. It's another. So, it doesn't even care if it's a tree or a shrub. There's a shrub called mule fat. It attacks that. It's like, oh my goodness. Avocado is the huge one. The avocado industry put a lot of money up front into the initial research because it was starting to devastate their industry. Ouch. So here's another lovely pest. This instead of a fungus, is a bacteria. This is called Xylella fastidiosa. Great Scrabble word, by the way, along with xylem. See how that word is close to xylem? It's got an X and a Y. Ooh, remember that. Xylem is Xylem. So you can kind of guess that Xylella, this bacteria, attacks the xylem, so the wood, the basic wood of the plant. And this bacteria is vectored by this little guy called the glassy wing sharpshooter. It's a little leafhopper, but it passes this bacterial disease from tree to tree, and it is named, the common name for the disease kind of differs depending on what plant it's attacking. There's oleander leaf scorch. This is what's killing oleanders. Pierce's disease, that's what it's called in grapes. There's almond leaf scorch. They kind of give it its own little special name, but it's the same disease. It's the same bacteria. So we're finding it in more and more of our urban trees. Our evergreen magnolias. I'm going to go fast here. Purple leaf plums, if they're not looking too hot, it could be this. Sweet gums, liquid ambar. Olive, Victorian box. So it's, it's something we need to be thinking about. So here is the soil texture triangle that, pressed the wrong button there. It looks at the percent clay and silt and sand, and this is how we name our soils. When I was talking about soil permeability and soil type, the more clay in a soil, the slower it's going to drain, right? So this is, like there's clay loam, there's silty clay loam, silt, there's loam. They all have different names. So if you have ever wondered, and I'm sorry, I'm going to have to cruise through these pretty quickly. Here's the Calypsy website. You can look up what trees or shrubs are invasive. If you're trying to choose what's appropriate, here is a list of invasive trees and palms. I'm going to just, like I say, cruise through here because I'm running out of time. PlantRight is kind of a split off of the Calypsy website, and it is geared towards nurseries, plant nurseries, trying to get them not to grow and plant invasive species. It kills me. I still see pampas grass, which is so invasive, or fountain grass, pennisetum. Cetaceum, still sold in nurseries. How can they do that? Our state spends billions of dollars trying to deal with invasive species, and yet, here, grow this in your yard. It's ridiculous. Anyway, that's PlantRight. SelecTree, here's what that website might look like, where I typed in the name of the specific tree I was looking for, and then it has a big list. These are all the different attributes that you can search for. And there it is. It's SelecTree, or really SelecTree. There's only one T between the word select and tree. And there's no www at the beginning. So it's selectree.calpoly.edu. Excellent website for a tree search. Climate-ready trees. This is the great new thing that's happening. It's a 20-year study that just started. They just finished planting the trees last year. And it is a collaboration between the U.S. Forest Service, thank you, Nicole, and the University of California, and some other nonprofits, and there's a whole big list of different scientists that are working on this study. They're trying to find out what are some climate-resilient trees that we should be planting in our urban forest, because we need to cool our cities down, and our climate is changing. We can't do the same old, and plant the same trees we have been that need more water, that are not adapted to a warmer climate. So they looked at areas like the Eureka and Berkeley situation. So they're looking at trees that come from even warmer and drier climates, trying them out here, doing a 20-year study to make sure, is this tree going to become invasive here? Or will this tree really be susceptible to lots of pests and diseases? So they're trying this study out. They're looking at all these different things because we need to shift what municipalities have on their approved tree lists. We need to be smarter about how we proceed. We really do. It's so critical. And on the back table is a list of the trees that were grown for this area, what's considered the Inland Empire. Here's a state. They split the state up into 3 basic areas, main areas, that they're concerned about. That big area, that big area is the Central Valley. That would be what they call the Inland Valley, or the San Joaquin Valley. Then where we are right now is considered the Inland Empire. And then there's the Southern California coast. And I zoomed in a little more to show you. So we are standing right now in that green area, the Inland Empire area. So they planted trees specific to those areas to see what would possibly do well. And this is some of the characteristics that they were looking for. What kind of moisture does it need? What's the pH? How tolerant is it to drought and wind and salt and cold? What are the major pests that it might have or it currently has? What may it be susceptible to? So there was a lot that came into play. And they came up with some areas to plant. So this is for our region. This green area is where they planted trees for the coastal zone. And over here is where they planted trees for the Inland Empire. So for this area. They came up with 12 trees to try out for your region. Here's a list of them. And like I say, there's a handout in the back. So they looked at different trees for California. Now the desert willow is planted already, but this is a specific cultivar called Bubba. I don't know what makes Bubba better, but they're trying this one out. And some of these trees are already planted, but they want to see how well they will do. So because there's not a lot of research on it. And like I say, there is the handout in the back that has all of this. They picked a tree from the Southwest. It's a mesquite that does not have thorns. That's a good thing. This is something from the Sonoran Desert, Apollo Blanco. This used to be considered acacia, but they've recategorized it now. It's Mario Sousa. Mario Sousa must be hanging out with Carmen Miranda. But anyway, West Texas, Oklahoma, Australia, there's a couple of species. Now, I'm very curious because the Polyphagous shothole borer, acacia is one of the trees. Any species of acacia is on the list of the trees that are reproductive hosts. So I don't know why they chose that. This one is a really beautiful tree, the rosewood. They have some of those even in Griffith Park. They're trying it for both of the areas here. And down below are 2 trees that are hybrids. This is Desert Museum. It's planted a lot. It's a Palo Verde, and then a type of hybrid pistache called Red Push. So those are the trees. And again, the handout is in the back, and I want to thank you and to have you start thinking and spread the news that we need to be smart and strategic to where we're planting trees. We need to cool down our cities. We need to be thinking about better ways to manage our urban forests and even our own little plot of land. Cool our homes, cool our neighborhoods. We need to cool down. Thank you very much. So, let's go for some questions. Yes?
I have a question because in our neighborhood, a lot of trees are...
It's hard. So you probably actually need to be watering more on the property side. So if there's lawn there, because remember that root system is very wide. So you have to get out of your mind that it's just in the little cutout where the tree is. The roots are well beyond that. Or just get water in the ground how you can, but you need to think beyond the little space and where the roots may be and try to water there. I think. She was saying that tree people, in fact, I have handouts on the back table to help support the restoration work we do in the mountains. So we work in the Angeles, but we also work in the Santa Monica Mountains doing restoration work. So you can dedicate a tree to Mom or buy a grove of trees, and that helps us pay for that restoration work that we do. So thank you. Yes?
Your talk covered lots of different things.
So he's asking about how they go about choosing the best tree for the site. He says that it seems to him that the best tree for the best cooling would be big, large, lush trees, and that would need a lot of water. And that's not necessarily true. So some trees are big and don't need a lot of water. So that's what they're looking in the climate-ready trees. And if you go to the WUCOLS website, you can look for very low water use trees that get big, that don't need a lot of water. That's the problem that we've had, that people have an idea that to be big and very dense, that they need a lot of water, and it's not true.
What's an example?
Of something that's big and doesn't need a lot of water, it just kind of depends on where it is. I mean, our oak trees, look at our native oaks. They get huge, and they need very little water.
But they have bugs.
What grows fast? You know, fast, I mean, you want fast.
Lots of questions. So again, it depends on your soil. On that SelecTree website, it also tells you the growth rate, whether it's slow or moderate or fast. So that's the SelecTree, selectre.calpoly.edu, and you have to be a little cognizant of the speed of growth. Some people think of oak trees as being very slow, and that's not really necessarily true. And some trees actually speed up their growth when they get older. So some of us, it's not such a bad deal getting older. But some trees that grow very fast tend to have weaker branches. And that is sometimes an issue with acacia trees. They're fast growing, but they tend to have weak branches. So you have to weigh both things.
I think we'll close the regular question and answer. I just wanted to tell you that Linda will do another informal question and answer after the program is over. And so we're going to close the regular question and answer so we can kind of finish on time. Marge Nichols has a gift to give to the speakers, so she'll come up now and do that. Thank you.
Well, we really appreciate the interesting information that applies to really everyone. And we'd like to present you with a small gift, a box of chocolates. Let's see. Which is which? Linda?
That would be me.
Yeah.
Thank you.
That's the idea. Thank you so much. Thanks for coming.